I think Control Islam, we can start, I think. Okay, gentlemen. Okay. Assalamu alaikum. Good afternoon. It's our pleasure as the Spark for consultation and technical support to introduce our engineer, Islam Abdel, one of our instructors here in Spark, who will delivering the free to our session in the field of process safety. Engineer Islam has more than 17 years in practical experience and strong technical expertise in this field. We are confident that this session will be provide a valuable and practical understanding for key process safety principles. Kindly request from each one to keep his mic muted. For any question, please write your question in the chat box, and our instructor will respond accordingly, inshallah. The floor is your Bashmans Islam.
Okay, thank you, Engineer Ahmed. Welcome, everyone. The voice right? You are hearing me?
Yes, it's good, Bashmans.
Okay. Welcome, everyone. I am pleasure to be with you today in this session. I hope we can manage it in good knowledge that can reach to each one. And the targeted knowledge we attend to reach to each one. We hope we could do what we want. So today we will explore process safety management, not just as a compliance requirement, but we will interact with the process safety management as a critical discipline that protects manpower or people, assets, environment, and also behave the business continuity for the factories and refineries. So this session will start as our agenda here, or our session content. It will be divided in this number of modules, 7 modules. We will start from introduction, process safety management, and define what is major accident hazards. We will talk about the history of the management system and from where it starts. Also, we will talk about RPCs, or risk-based process safety, and the systems that are behaved with risk-based, and what is the advantage of risk-based upon other management system. And at the end, we will be open to any question or discussion from any one of you. Bismillah, let's start. At the beginning, the introduction, we want to know what is meant by process safety, or what is the concept of process safety as overall. The process safety is a management system or engineering system designed to manage the hazards and risks associated with the hazardous materials or hazardous chemicals or energy that may be introduced in the production process, or any even at the storage of the chemical hazards. All these processes can be introduced as hazard and risk from this material. The core or the ultimate goal of the process safety is to prevent the occurrence of major incidents or major accidents from these chemicals. Other way, there is a proper difference between what is process safety scope and occupational safety scope. We will talk it about in the next slides. But we must ensure that the process safety goal or ultimate goal is to protect the human assets, environment, and even the business continuity, as we talked. All of these are targets for the process safety. A variety of process safety structure has been used. some based upon regulatory requirement like OSHA. It act as an act which act as a law in our country, but in USA it act as a law that must be regulated for all chemical industries that may have hazardous chemicals or energy which have a potential to cause damage or incidents in its process. A main concept is provided for the process safety management is that the process safety management application work as a proactive, not reactive. The main purpose of proactive is to prevent the incident or the event from happening before it's happening. There is advantages for this proactive concept or principle upon the reactive. What are these advantage? The proactive is implementing countermeasure to prevent an incident. I work on the measures to prevent the incident before it are done. But the reactive, these countermeasures is after or its response after the incident has occurred. Also, hazard analysis and risk assessment is performed before the task or the activity is started. While in the reactive, we don't perform risk assessment, but perform incident investigation as the accident is already occurred, and to determine the root cause and identifying the root cause of the incident to prevent reoccurrence after that. Also proactive, it started from the design phase as we practice more for inherently safe design as the inherent safe design of the facility is more safe and considered all the risks and the hazards, it will prevent major hazards accident from occurrence. While the reactive, it is management of a change and the addition of layers of protection after each incident according to the incident investigation and the root cause analysis considered, which will output recommendations for adding additional layers of protection after the incident is occurred. Okay, the main concept or the main hazard we take care of it in the process safety is the loss of containment. What is the loss of containment as a whole? The loss of containment as the hazard material or the harmful substance or energy is considered inside its pipeline or the equipment which is designed for dealing with the substance. We can control the substance and we can maintain our safety from this substance as it is in the pipe or inside the equipment which meant to contain it. But as this substance or material as it is in case of storing or in case in storing or handling or manufacturing this substance, all these processes are maintained to be safely as the material is inside the pipe or inside the equipment and controlled by the parameters of this equipment. But when this material or hazardous material gone out the pipe or the equipment, it starts as to be a loss of containment incident. This loss of containment incident, we can't predict what will done from this. This hazard material may be flammable that reach to an ignition source and cause fire, may be explosion, may be toxic or this material is toxicity or flammable, has a reactive which will reach for water and cause runner reaction, which will cause fire also. As the material gets out of the pipe or the equipment, we can't control the consequence of the hazards from this material. So that's why the process safety main concept is to control or maintain or prevent loss of containment of the hazardous material from its place. We have to differentiate between what is the process safety and the occupational safety as a whole. We will not deal a lot with this item, but introduction or a general definition for each one of them. The process safety is for preventing, as we have to get the concept of that process safety is always proactive. It will prevent and to be prepared before the incident is occurred. So the main concept of process safety is to act proactively than to be reactively. Okay, as we said, process safety is focused on preventing and preparedness and mitigation of the consequence. We also have to mitigate the consequence and response to it, restoration of catastrophic release of chemicals or energy from an industrial chemical manufacturing process associated with the facility. While the occupational safety, it focuses on preventive injuries and illness for individuals, for every employee, due to their task or work environment. As such, it tends to focus hazardous energy related in personal momentum. What is meant here, or what the point of view here, is that occupational safety act for prevention, but prevention of the injury of each individual alone. As we know, the major accidents here is to fall or trip or slip. All of these are individual risks. Occupational safety is responsible to maintain the employee or the worker away from these risks. Also the occupational safety varies with great names that somehow it's HSE or EHS or it's SGE. The Border Area Act, but all of this will cover the health and safety and the environment of the facility. Also, somehow some facilities or some systems added the quality and security to the HSE also. So let's start with the difference between process safety and person safety overall. This drawing or this figure, these triangles will act if we look downwards here. We will see here are the human risks, which is the human behavior, and the man-machine risk, or the interaction between the men or between the individual and the machine. Even the machine is rotating machine, this individual will interact with rotating, will cause, or there here will be a risk that raised from the rotating machine on this behavior, on this man behavior, according to this man behavior. Okay, so that's why we will start the downwards with the behavior or unsafe condition. As the individual is interacting with the rotating equipment or rotating part without protection, or this is unsafe condition. From the unsafe condition is always considered for the equipment, and the unsafe behavior is always considered for the individual. Unsafe behavior is for the individual. Unsafe condition is for the equipment. After that, the injury may be a first aid or serious injury, or at last it may be fatality. While here in the process safety, it taking consider the occupational triangle and exceeds above it by its focus on an overview or a large view for major accidents and more consequence that released from these accidents. The integrity risks involving resources here, the first aid is the incident, then occurrence with loss. This loss, as we will see later, may be in the human or worker or even public or assets or environmental or the continuity of the business itself. Then it will be a severe occurrence for individuals, and at last it might be multi-fatality, and the explosion and the fires may cause multi-fatality than a single interaction with an equipment. Okay, the occupational health and safety, as we said, it is individual oriented. It is for each worker or each individual by itself and controlled by the individual itself. The behavior of commitment of the individual is the main safe for this individual. Okay. Also, it focused on direct interaction between individual and the equipment or structure, as we said. Specific impact. This impact is specific on the person or on the individual interact with the hazard. The workplace rules and the safety equipment. As we said, each equipment has its safety precautions that must be maintained from the interacted human. And also the workplace has its own rules and specification and requirement for the safety situations around each task. The training of the worker act as a barrier as a barrier for the human safety, and also the supervision as if the worker take bypass or shortcut from a procedure or from a safety precaution, the supervisor will show him the right way immediately. Example of possible incidents, as we said, it's fall, slip, electrocution, asphyxiation in cases of confined space, hearing impairment for if the person is working with high loud or high noise equipment for a long period, minor injuries also. All the signs must be taken in the occupational safety, starting from as we take it, if we take it as a general quickly, this will be the PPE. This is the exit escape routes in gas. If gas is detected or entering confined space, we need a breathing apparatus. The first aid for small injuries, radiations, also the hazard of electricity, smoking as a source of ignition, non-entry confined space or non-entry restricted area. Here, any alarm must be notable by a sound, by a siren sound, and by lighting lamp. This siren must be determined according to the situation of the emergency, and also the people in the facility must be trained on this sound to have to, as they have to identify this siren, as a response will differ according to the level of the situation. Also here, to stop of work, our stop work authority, this stop work is according if any hazard or risk is raised after the risk assessment of the task or the activity is occurred, you have the ability to stop the work until this risk is mitigated or controlled. Here is the escape also, and here for attention. All these icons or this safeguards. We have also the safeguards that may be considered during the occupational safety any activity must have its work permit. The work permit is a strong communication tool that will prevent the occurrence and will study the risks and control it in a behavioral way. Also, the PPE or the personal protective equipment. In case of confined space, we have to make a ventilation system, guardrails for working at height activities, and equipment guards. As we said, rotating equipments need to be guarded well. Okay. IOGP is the International Association of Oil and Gas Producers. They produce what is called life-saving rules. It is more attended or more structured for occupational safety. As we see, it consists of 9 rules. This 9 rules is used to maintain the individual in safe condition. So as we maintain our definition from the beginning, process safety, occupational safety is for individual, while process safety is for major accident hazard. So life-saving rules is considered for the occupational safety. Quickly, we can take a look upon them. First is bypassing safety control. Any safety control don't bypass, even in case of maintenance. We must provide or introduce a redundant tool or redundant way to maintain the safety of the place. Also, entering confined space, the driving and safe driving, limit speed, or using the seat belt. Energy isolation. Energy isolation is not only electrical isolation. Energy isolation is for electrical and mechanical isolation, as we must maintain zero energy from both causes. Hot work to control all works that may introduce heat or may introduce flame. Also, line of fire. It is a behavioral as the person by itself have not to move under working at height or move inside, move in front of a moving machine or a moving equipment, and also during venting or draining pressurized pipes, he must be away from this line of fire. Also, safe mechanical lifting and work authorization. As we said, permit to work system must be authorized for all tasks and activities, and at last it is working at height. Okay, while for process safety, as we said in occupational, it is individual oriented. Here it is cooperative. As we add a group inside the facility, each one commitment to the process safety will prevent and maintain safety for all the workers in the facility. And also, it must be a broad impact, as the impact will affect a large number of peoples and assets inside the facility. It is systematic. The system must be controlled. The system must be put in order and not as activity. Each one can do what he wants, and at last it is a little individual control, as it is a systematic system. This system will cause that most of individuals or and management level will introduce its behavior inside the system. The possible incidents in process safety, they are controlled as fire, explosion, and release of hazardous chemical or energy. These are the main possible incidents, but inside each one of them there is a variety and a large number of scenarios that may cause each one of them. The safeguards, as we take that we will impose safety, we act proactively. In proactive, we will need to start from the inherent safe design, as we said before. So here we can put pressure safety valves to prevent overpressure in vessels and explosion. We have to inherently safe design. We can make equipment interlocks to take rapid action to prevent catastrophic situations, and also process alarm to trigger to make the human interference more quickly. Also in the operations, we have to make maintenance, or not as general maintenance, but the scope is preventive maintenance. As the preventive maintenance will be proactively preventing the cause of these incidents. Also, the engineering and inspection, as we inspect that the equipment is reliable and able to control the pressure and the temperature and the parameters of the process introduced to it. Also, the training of the employee and front workers, it make a great impact in saving, in making procedures or maintaining procedures of the system to be a commitment, and also the procedures itself, as the procedures is found and the workers and frontline work from the scope of the procedures, they will prevent a major accident hazards from occurring across their processing facilities. Okay, also the IOGP introduced 10 process safety fundamentals introduced from the scope of the process safety. As we will take a look on them, there are 10, starting from maintaining safe isolation. As we said, safe isolation here is for mechanical isolation and also for electrical isolation if found. Walk the line, we introduced to walk across the facility or across the unit and pipelines to ensure that there are no leak or loss of containment from any place. As we said, that loss of containment is the big dangerous situation process safety Act 4. Also, applying procedures, as we said, that the procedures of the system must be maintained and applied in a well behavior. Sustain barriers, we have to prevent our barriers. These barriers is the human barrier itself by training and competency of the person or the worker in his task or place. Also the alarming and also the integrity of the equipment. These three barriers must be sustained and maintained all the time. Also containing ignition sources. These ignition sources, as we said, it acts as the hot work in the life-saving rules. But here we have to control all ignition sources from hot work and non-hot work. What is meant by non-hot work? We have another ignition sources, the traffic and preventing cars from moving or restricted from special places or special pathways, as they may act as ignition sources, and many other situations. We can talk on them later. After that, it is the mock or management of a change. We have to recognize each change, not to introduce or raise as another risk or unhidden, unrevealed risk may be introduced in the situation if this change is not studied well and revised from a specific persons. After that, we have to respect all type of hazards, electrical hazard, flammable hazard, or explosion or pressure that may lead to explosion. All these hazards must be respected and introduced in a well manner. You have to stay within operating limit. Each parameter inside any facility have its minimum and maximum limit. This minimum and maximum limit is introduced from the vendor or from the creator of the system as a safe limit for this operation. So we have to stay in this safe limit to do not introduce any new risk or hazard in the situation. As we said, we have to stop work if unexpected occurs or a new hazard raised. Also watch for weak signals. Any weak signals, any near misses occurred, we have to watch it and investigate it, as we have to investigate every near miss, but not we have to investigate it slightly to know a lesson learned or to know how to prevent reoccurrence of the near miss, as this will act as weak signals. Near misses act as weak signals for a huge accident or a major accident. Okay, we will start module 2, but firstly, if anyone have a question, we can take it. Chat box, we can see the chat box. Okay. Okay, let's start. Module 2 is the process safety management. As we said, the process safety is a systematic method. This systematic method must be provided continuously and effectively to control the hazards of the entire process lifetime. Okay, we also, as we said, that this system or this management system is work in conjunction with the existing standard of the environmental compliance and the product quality, and also the occupational health and safety found inside the facility or the place. Okay, what is the importance of the process safety? The importance of the process safety, because as we said, loss of containment events in the process industries can have a direct consequence for employees and public and the company itself. So that's why we talk that process safety management is looking for preventing loss of containment event from the operations. As several major chemical catastrophes have demonstrated the need of effective of PSM and potential devastation, as we will see in the videos we will take care of it. Okay, let's consider what will be affected by the process safety measure accident hazards. As we said, at the first, it's the workers, as they are the front line. The worker is affected by this catastrophic major or serious major disaster, even by death or severe injury or long-term health problem, or affected personal monetary success if the injuries and health problem interfere with the future work. As if an accident occurred, the worker may be still afraid or has its own fear from doing this task again, or preventing or conducting this task in the future. Also, the public will be affected public will be affected by death or by severe injury or by long-term also health problem or economic problem, as somehow um, the facility may have to pay money for public, or the facility itself, it must be regulatory punished. So all of these are economic problems, community longevity, and environmental health affected by public health and safety. Also, we have an environment impact on the three types of the environment: the atmospheric, the air quality for the human and animals and vegetation will interfere, and also the terrestrial environment uh, will contaminated, and also aquatic, even if it is salt water as seas and oceans. The creatures or the ocean aquatic creatures will affected, and in sweet water irrigation and the drinking will be affected. Also, as we said, the business continuity will be affected, so the corporate losses will be disaster only also for this. The cleaning up or the cost of cleaning up uh, is very effective thing in the cooperative losses. As we say in deep ocean accident, the cost of cleaning up of oily spill from the water of the ocean was catastrophic for the company. So cleaning up is very expensive activity. Also, the productivity, the damage can affect the productivity, employee morale, and attractive as an employee. As an employer, the damage of productivity as a continuity of productivity. If an accident occurred, the productivity will stop, and this will affect the continuity of the productivity. Also, the product quality, even minor accident will affect the operation integrity, may affect the product quality. Also, the insurance, all facilities or all facilities that have highly hazardous materials or highly chemical materials used, they have to insurance their assets and their facility. As the accidents or the major accidents occurs, the insurance budget increase. So better safety history can lead to lower injury compensation payouts, which in turn can affect insurance cost. Also, at last, is the repetition of the facility itself. Uh, turn is bad as an employer, decreasing productivity. Okay, that's how, or that's why we are talking about the consequence of major accident hazards or hazard incidents. The consequence may be or can be extensive. Not only can they cause serious loss of life, injury, and property damage, as we said, they can also seriously harm the environment and affect the company's bottom line. As we see in the previous slides, that the human and the community, also the environment by its type, and the cooperative itself will lose its name or its budget cost in the case of these accidents. In fact, serious loss of containment incident can lead to financial crippling of the company. As we said, the cooperative loss will be catastrophic. Okay, module 3, we will talking about major accident hazards. In this module, we will take sample of catastrophic disasters occurred. Here we are taking starting from each disaster of this have its number of fatalities and injuries, and have the main cause or the main cause of the accident is here. As we see, we will start in. Anyone hearing me? Hello? Okay.
Yes, I can hear you.
As we said, each catastrophic disaster of this is caused by a specific cause or a specific root cause. Also, this is another patch of the
Maybe something wrong happened, I don't know. We'll try to solve.
Hello.
ايوه يا باشمهندس كده سامعين.
تمام. We will start a video here for Viper Alpha accident.
Was the world's most successful oil rig. What that means was that in a single day, Piper Alpha produced more.
Confronted by 700-degree flames, most of the 226-strong crew are now either dead or severely injured.
The nearest analogy is that it was a cross between Titanic and the Towering Inferno.
July 6th.
Okay, as we saw in the video, this is one of the most catastrophic accidents across the history of the oil and gas sector at all. Okay, how can we act with these major disasters? We now have to investigate the accident after it's occurred to know the root causes and conclude the lesson learned to prevent reoccurrence of such major accidents like this. Okay, here we will not deeply take details, but as overall, how to deal with this accident is the date and the location. Also, the incident type is explosion and fire due to gas condensate reinjection pump leak. This is a description, the number of fatalities and injuries, and the cost is about 2.4 billion USA. That's how, for anyone that think that safety or even occupational safety or process safety is expensive, the famous quote is try an accident. So if you try an accident, the cost will be very huge according to the cost of preventing safety to prevent the occurrence of the accident. Okay, here this is also the incident description, and after that, that's the main purpose. Is there is always a basic cause or a direct cause that the accident occurred by, and also there is a root cause. This root cause is the most important, as the root cause must be recommended to be resolved. This is the main cause for this accident, not the basic cause, which will be direct and primary for the accident. Here, the root cause is the work permit system. Also, the shift handover between the shifts was not properly, and we will get to these root causes one over one to introduce what caused inside the accident. And at last, there is a lesson learned. This lesson learned must be also communicated across the personnel in your facility to learn from experience or to learn from past accidents occurs. Here you have the CSP is the Chemical Safety and Hazard Investigation Board. All these videos are provided by and investigated by this board. There are a media library or a video library, a huge video library across many industries and many situations. You can go and benefit from this site a lot. This is another accident, but we will go on for the time. Here we will, if anyone has any question, okay. Okay, we will start with the history and to know how the management system is initiated and come from. At the beginning, the history for the occupational safety. The occupational safety started here over 100 years ago in some cases, and I think it's over that number of years. I think it starts from the revolution, the industrial revolution. I think at 1802, in some the employee or the workers in mines, they started with simple safety precautions. When introducing the trains, they also the workers at the trains also has safety precautions. It was simple, but it starts from that time, I think. So let's see that, or let's say that the initial focus of occupational safety was over 100 years ago. In some cases, the establishment of occupational health program as illness due to chemical exposure become a known hazard. The establishment of environmental program as public concern increases, and regulation were programmed to protect the environment. All of this was started, and for process safety programs, it was started, or it started from 1990 as a guidance and regulation for proliferated around the world. What is the management system? As overall, as we said, it is a formally and documented set of activity designed to produce specific results in a consistent manner on a sustainable basis. The modern management system is characterized by IDEM, PIMP, and ISMIC. We will look for each one individually. The IDEM is short for or it acts for the goal of safety management system. It is the reason why a safety management system is implemented. That's why each letter indicate a concept. LI is for identification of all hazards. Then we will evaluate this hazard as associated risk, develop a plan, implement this plan, and then monitoring the plan. This concept is updated nowadays to what is called PDCA cycle. PDCA for plan, do, check, act. For every activity or task or every a system to be considered, we have to make a plan and then starting to implement what we do or what we plan for. Then we have to check and monitor what is implemented, and then we have to act to improve or update our plan. Okay, then PAMPA is not a system as it identifies the parameters or the parameters the system must include or show. That's why it helps to understand the different and multiple safety activities that are needed to compose in safety management system. P is for people as a personal or frontline employees or workers, and the public around the facility, and the third parties as contractors or suppliers, or even that may supply something for the facility, or contractor that may an external activity or external task. All of these third parties as a contractor for inspection, for maintenance, any type that must be considered. Also the materials as raw materials, and as we said, the storage of the raw materials of the hazardous chemical must be maintained in the system. The end product and the waste and utilities must be considered also during the safety management system. The equipment as machines and tools and the installation must be considered. The environment and the worker environment and the environment food sense, and also the processes as the organizational process or the production process. All of this must be considered or considered by the safety management system. The last is ISMIC, and it is a method for the activity, not as ISMIC is method for implementing the system itself. The I is identification of the work or activity to be done. As for standing established, as we will identify the standards that will be work as a reference for our safety management system. We must ensure that we have a recognized standard, measure the performance of the work done, and evaluate the efficiency and effectiveness of regular basis. And at last, we have to correct or to improve if any correct is needed or improved is found. That's why the life cycle of the management system will start, as we said, by it, as we will introduce what is the PDCA cycle. We will start from plan. So the plan will be to develop a design specification, and then we will start to do to create element and workflow, and then we will estimate element and system workloads, and then we will develop the written programs and procedure. Then we will start rolling out the system, and then we will monitor in the check step. We will monitor implementation and the initial performance, and then we will act at last to improve or update the system if found. There is a PSM intensive across the worldwide. There are many incentives produce post safety regulations and guidelines. Somehow there are many nationality here, but I want to add something that even if you look for the European Commission, CVSO directive is CVSO is an accident. You can revise it at CSP site. CVSO was an accident in Italy, a catastrophic accident in Italy that have a bad impact and huge damage. So that's why here it starts as a law or directive for according to this situation and updated by time. Somehow, some nationality produced the regulation or the standard according to a catastrophic accident occurred on her lands, and somehow it is a study or an overall regulation for all the facilities or all the industries inside the nation. We have to, after that, we have to maintain that we can't reach to the zero level risk. There is no identification for the what is known as zero level risk. Also, the post safety management system will participate and communicate, but cannot consider that the risk will reach zero, as the system of the post safety will be created and introduced and rolled out across the facility and then implemented and trained for the participants in the system, but not once. This, as we said, that this system have to be monitored and improved and updated by time. Each time you will have a defect or unrealized risk will be improved and updated. So the system will still be dynamic and interactive over time. So we will not reach what is meant by zero risk. And the famous quote is, "You can't lose if you don't play." So if you don't want to lose, simply don't play. Okay, here we will talk about the overview of risk-based process safety and from where the risk-based concept come. The risk-based nowadays is considered in all management system, even the asset management system, the asset integrity management system considers the risk-based. The ISO management system considers the risk-based, and also as well the post safety management system is considered by the risk-based but from the priority of using risk-based was the process safety management system. Here the process industry have evolved several strategies. Okay, are you hearing me?
Yes.
Okay, the strategic approaches started from the standard-based strategy. This strategy was based on following the recommendation and specification of a standard and be aligned with this standard. So That's by this way we maintain our strategic system to approach chemical accident and loss prevention. Previously, it was a compliance-based strategy. As we said here, as we said, OSHA regulation for post-safety system, or the CPSO, as we said, for the European Commission. Compliance with this based strategy will lead to preventing also chemical accident or loss prevention. Then it was a continuous improvement based strategy as a management system provided by the experience of the place. So each place have to improve its strategy according to the experience and continuous improvement across its facility. And at last, it was the risk-based strategy introduced by managing risk by evaluating the size of the risk and the amount of the risks found and how to manage this risk. That focus primarily for the risks and how to manage these risks and the best way to prevent the risk or the hazard to be introduced as a risk that cause a major accident hazard in each case. That's the four types of strategies. Somehow the risk-based is a more mature, but there are some facilities or that may have or not a totally facility, but some disciplines inside facilities that may be using the standard-based strategy as also we can say that the inspection engineering and inspection disciplines inside the facility, they have its own risk-based strategy right now, but they must be follow the standards as API or ASME in their regulation and their activities. There are three main post-safety management systems that are most common across the world. They are the most famous post-safety management system, starting from the OSHA for Occupational Health and Safety Administration. It was started in 1992 and consists from 14 elements. All these 14 elements act as a system to ensure that all the risks are controlled inside the facility and to maintain the highly hazardous materials and highly hazardous chemicals from causing major accident hazards. Also, the second was the Center of Chemical Process Safety. This is originated or published at the first in 1989. It was consist of 12 elements only. Okay, and after that in 2007, it was updated to 20 elements by the foundation block like that, consists of 4 pillars of risk-based process safety. The first pillar is commitment to process safety, then understanding and hazard and risks, then manage risk, then learning from experience. These are the foundation blocks of the risk-based process safety. Nowadays, the CCBS Process Safety Foundation is the most popular considered, and also the third one was the Energy Institute, according to the European Energy Institute, and also it was focused on 4 areas or considered 4 pillars with the same vision of CCBS. It was published in 2010 and then updated in 2013, consists of 20 elements. If we look for the 20 elements for the Energy Institute, we will see the similarity between them and between the CCPS foundations. That's why we are saying or talking about that the CCPS risk-based is most used or most popular now across the world, as the Energy Institute is extended from by a way or another. They are very similar to each other. So here in Egypt, the EGPC or the Egyptian Petroleum Corporation start using the CCPS as a reference for all its facilities and cooperative. And there is a perfect site now for the Egyptian PSM. The link is inside, is in front of you. If anyone want to take a look for it, it have now a huge library of guidelines and standards that may introduce good knowledge and good modernization for the CCPS elements, and started as they are started to develop in Egypt facilities right now. Okay, there is here we can talk about what is the how to deal with the risk-based system. Here, as we said, that CCPS started after the disaster of Mexico City and Bhopal in India. Also, Bhopal, India was a major and catastrophic accident. You may see it, as we said, on the CSP link. Here we saw the CCPS started to prevent a chemical. We have to identify three questions, or you have to ask yourself three questions if you want to identify what is the risk. First, what can go wrong? Okay, then how bad could it be? Then how often might it happen? So each question equal to strategic based, as we said before. What can go wrong is equal to the hazard based. What can go wrong? You will identify the hazard found that will cause the risk. How bad could it be is the consequence of the risk, and what are the consequences that are prepared or built up upon the risk, and how often it be is the frequency based. That's why risk-based term is used to mean any one or combination of these terms. The primary of the risk-based is that it will equal to all this strategic based. So it is complicated in itself, but will give you an overview for the risk introduced inside the activity or the task you are working on. As we all know, risk is equal to likelihood multiplied by the consequence. This is general situation, but we have recognized that all hazards and risk are not equal. Advocates that more resources should be focused on more significant hazard and high risk approach are built for 4 pillars. As we said, the 4 pillars was for commitment of post safety. We have to commit to implement and act for the process safety. We have to understand the hazard and risks around us, and see how to control and manage this risk. And at last, we have to learn from the experience accidents, as we said before, and we see in the videos. We have to learn from this experience to prevent reoccurrence of the accident more time. The pillars is divided into 20 elements, not equally. We will see it later but we have to design a process safety management system, correct the efficiency process safety management system, and improve process safety management practices. Somehow there are some causes for the incidents to be grouped. So the causes are categorized in the technology failures. Somehow the technology equipment or the technology application cause failure. That somehow, and somehow there are human failures. The human itself may cause failure. Also, there are the management system cause failure. If the management system is not updated or improved and monitoring in a proper way, many failures may be introduced from the management system itself. And at last, the external circumstances and natural phenomena that may not be controlled by any way. We have to be talking about now the total life cycle across the facility. The total life cycle of the RPC's elements is meant to be applied to the entire process life cycle. But here we have to say an important issue that was faced during the practical implementation of process safety in facilities. Somehow you must consider or must be know that the system is not as a package. The system is not a whole package. The 20 element as in CCPS or the 14 element on OSHA must be developed and implemented in the same time and as a package. Somehow during the life cycle of the project itself, some elements must be introduced in a specific phase, and another element will be introduced later. And at last, we have to overhaul the management system, but not as a bunch or a package at the first. Even some elements requirement is not mature enough to develop the element. So as we written here, some elements may not be active in early life cycle stages. During conceptual design, there is a little need for developing operating procedures. That's an example. Other elements may be active, but the information available in early stages may not be very detailed. Therefore, the work performed in that element would be more preliminary. As the hazard identification and risk analysis element, it must be considered in specific stages across the project stages. For some elements, however, the early life stages provide a unique opportunity to minimize risk by identifying and incorporating inherent safe process characteristics. Or somehow, in last stages, as after decommissioning, there are no longer need for the maintenance procedures as the facility is decommissioned. That's how we are talking about stages, and to identify the requirement and the needs of every stage during the total life cycle of the project. Also, some activity and facilities are not considered in the scope of the process safety, as the transportation. Transportation is not considered in the scope of the process safety. The storage itself is considered, but the transportation between storage is not considered. That's why, because the transportation or the application of this operation was not developed until the RPC's guidelines were developed. So transportation is not considered in the scope of the process safety. Also, the products and the specification of the product, the quality management and quality control across the specification of the product is not considered in the process safety scope. The process safety, the major accident hazards will affect the product's quality, but the process safety is looking for preventing the major accident hazards. Otherwise, they does not have the quality, the specification of the products or the situation of the product in its scope. Okay, as we said, we will talk about we will consider the CCPS Foundation 20 elements to talk about here. So it was divided into 4 pillars, as we said, or 4 foundation blocks. The first pillar is for commit to process safety. It includes 5 elements. Then the second pillar, foundation block, it understand and evaluate hazards. It considered 2 elements or consists of 2 elements. Then the third pillar, manage risk, 9 elements. Then fourth pillar is for 4 elements, learning from experience. We will talk for each one by one quickly right now. Focusing on these 4 foundation blocks should enable an organization to improve its process safety effectiveness, reduce the frequency and severity of incidents, and improve its long-term safety, environment, and business performance. The risk-based approach helps avoid gaps, inconsistencies, and excess work, insufficient work, and rework that can lead to system failure. For process safety management system to work most effectively, companies should integrate their RPC's practice with other management systems. As we said, the management system must be integrated with each other. If the facility have isolated asset integrity management system, must be introduced and integrated with the process safety management system, and also the quality management system, or the power saving management system, or energy saving management system. Any management system introduced inside the facility must be integrated with each other. So this product quality, equipment, and human availability, personal health and safety, environmental protection, and even security must be integrated with each other. Okay, here we will start with module 6, risk-based system. We will talk about the risk-based system across the CCPS management system, as we will take example from each pillar, taking an element and talking about main points of each element as a sample from each pillar, as we see. Okay, we will start with the first block or first foundation, commitment to process safety. There are main items that must be considered for the commitment or the focal points. As we see, we have to ensure management cares and provide adequate resources and proper environment. The managerial level of the facility must provide resources for developing and implementing the element across the facility. Must also ensuring that the employee care for implementing the system, demonstrating commitment to stakeholders. We must also ensure that our stakeholders, or as we said, stakeholders as contractors and suppliers, or public surrounding neighbors, all these stakeholders must be commitment to help our facility in introducing the process safety management system. To commit to process safety, facility should focus to develop and sustain culture that embraces process safety. The culture across the employee and workers must be developed and must be raised by training and by awareness sessions, also by conducting interviews and interactions with the employee and first front line. Also identifying, understanding, and complying with codes, standard, regulation, and law. As we said, we have to identify a recognized standard for each task or each activity. So we have to identify these standards or regulations that will be applied and understand them and comply with them. Establishing and continually enhancing organizational competency. Competency is a complicated concept. The most major take competency as training, but there is a huge difference between competency and the training. Competency is not training. Competency is knowing knowledge and applying skills and with a behavioral attitude that must be applied for all the elements of the system and all the activities, not such only the experience of doing the task many times, but we have to be introduced by the knowledge and the skills that can be applied for the task to maintain safety and maintain preventing causing introducing a new risk or raising hazard that may cause be accident. Competency is a great knowledge. We can't. I'll try to make a hint about it, but it needs many time to talk about it. So after that, soliciting input from the consulting with all stakeholders, as we said, including employee, contractors, and neighbors, as we said. So the pillar consists of 5 elements. The 5 element is the process safety culture element, and then compliance with the standard, process safety competency, workforce involvement, and stakeholder outreach. Here we will take compliance with standard as an example from this pillar to talk about compliance with standard as an element in the first pillar. It is the second element. What is the definition of each one of them? We will start with codes. Codes are generally the top tier documents providing a set of rules that knowledgeable people recommend for others to follow that specify the minimum acceptable level of safety for manufacturing, fabricating, and constructing object. Codes here is mandatory to be followed. That's the main concept or the main difference between codes and standard. Codes must be followed, act as a law in somehow, so it must be considered by all the disciplines or by all facilities. Code is standard adopted by one or more governmental bodies and can be enforced by law, as we said. Example, ASME or API, all of these are codes. But the standards are documents that establish engineering and technical requirements for product, practice, method, and operation. Example, STM, ISO, API, NFPA. All of these are standards which have a technical or engineering point of view and the requirement to the product to be produced inside the limits of these requirements. Another types of standards and is the regulation generally issued by state or federal agency with public safety issue. The specification is provided for materials and component or service and often generated by private companies. So the specification may be differ from place to place, or also the specification may be differ inside the same place. from task to task or from activity to activity. Each company has its specification, but somehow some examples that the same company and have different specification from site to site or from place to place. Recommended practice are the documents prepared by a professional group or committee or company based upon good engineering practice. The recommended practice is act as learning from experience. According to our experience in doing this task or doing this job, we practice or we recommend to do it like that. It is a good behavior used broadly in many industries and has a great impact on many industries. But it is not you have to you may not use it if you not have the power of standard or a code. So that's the point of consistency across the recommended practice. Also, some examples, but here before we start, I have to add something. There is also what is called a guideline. What is the importance of guidelines? Guidelines is also a recommended practice or type of recommended practice according to the experience and knowledge of a company or entity or a specific discipline. It gives me the guideline. The most important here is the guideline is not mandatory. The guideline will guide you across the activity or the task, but you don't have to be aligned totally with the guideline. You have a variety of a choice or a variety of chancing to consider what you want or what you don't want inside the guideline. Why I'm talking about that? Because somehow, from my experience, somehow people catch the guideline as a law that must be regulated word by word, and that was not a good thing. That was give a bad impact, and somehow after that they realized that they need to update what they done before. Okay, some examples of standard and codes, as we see here in process safety, there is the CCBS and OSHA, and also the Energy Institute, as we said. Health and safety, there is ISO and OSHA also. The firefighting and emergency, there is the NFPA and the API, the American Petroleum Institute. Also, in hazard identification, there is the IEC, International Electrochemical Commission, and also operation. There is a licensor or the vendor manuals. Each unit in the operation have its licensor that all have the concept of how to deal with his package. So there is a licensor itself or the vendor manuals. In asset integrity, there is the American Petroleum Institute, the ISO, International IEC, and the ASME. All of these are used as standard and resources for information across the asset integrity. And at last, the laws are considered as an labor law or environmental law, which is mandatory to be followed across all the facilities. That was a brief about the element inside the first pillar, how to follow the standard and how to identify the standard you will follow and how to deal with it in developing starting to development and commitment to develop the system. The second pillar is understanding hazard and risks. This is the second pillar, consists of two elements. The focal point is to know what you operate. You must know the hazard introduced to your operation activity. Also identify means to reduce and eliminate hazards, how to eliminate this hazard and how to reduce their consequence. Identify means to reduce hazards and understand residual risk. What are the residual risk? Residual risk is the risk remains after you control. After you identifying the risk and identify how to control the risk, there must be residual risk that remain after you control. As we said, no one can reach to zero risk, so it must be ever and ever a residual risk after you control. To understand risk facility, collecting documentation and maintaining process knowledge to ensure or to know what are the risks or what are you introduced to. You have to follow the document or to have to know the documents that describe this operating facility to identify the risk from it. So the documentation is very important, as we will see later, and then conducting a hazard identification and risk analysis study to identify the risks that produced. As we said, there are two elements, process knowledge management and hazard identification and risk analysis. Here we will talk about both of the elements, as they are I think that process knowledge management element is the most important element across the system. Without this element, you don't know nothing. Knowledge is primarily important in conducting or developing the system. So without knowing the process knowledge management, you don't you will not be allowed to know something about your facility or process. That's how it is important. The process knowledge, we will take a quick information about it. The hazards are the resources to be studied. The term will not be maintained efficiently. There are unknown. I think the 3Ds are the requirement for the process knowledge. The 3Ds is for data, types of industry and materials, and documents and drawing. Data is the data for the process itself and the equipments used. Documents is the license of manual and standard operating procedure, and also the equipment list if found. And at last is D, the third D is for drawing, as plot plan, layout, PFD, PDF, P&ID, all this drawing, or also the isometric drawing, all the logic drawing, all this type of drawing are used to identify the risks and how to deal with this operation or process operations. Okay, the hazard studies. The hazards are classified according to initiation, project hazard studies, also the construction and commissioning and feed and process hazard and specific task. Each stage or each classify of this required identified type of hazard studies that introduced during this phase. As we see here, the PHA phases, the process phases from conceptual to design, construction, startup, production, and post changes. The design hazard analysis will be in the conceptual and design phase. Here, as in a new project, once the initial drawing for the facility as P&ID or PFD even start to be developed, we can start hazard analysis according to this initial drawing to evaluate any risks. As we said before, the inherent safety design is very important, so we must maintain and to control risks and hazards in the design phase as much as possible, as it costs lower than introducing after construction, and also it make a type of or act as in hierarchy of controls, as we said. We will see after that. It act as an elimination control for the risk to prevent occurrence of the risk at all. Okay, we will take it quickly for the loss of our time. Here, the post-safety knowledge is, there are types of post-safety knowledge, the technical documents and engineering drawing and calculation, the specification of design and fabrication, and also important the material safety data sheets, the MSDS. Also type of process knowledge, they are considered as three types: the chemical hazard information and process technology information and the process equipment information. The chemical hazard information is the information for each hazard chemical introduced in the operation. The process technology information is a description for the overall technology used by the vendor or by the licensor to be used across the process. And the process equipment information is the knowledge about each equipment by itself. A specific process equipment should be based on the type of equipment and the failure mode and consequence of failure for the equipment. In other words, the risk of each equipment. Okay, the chemical hazard information, as we see here, the material safety data sheet. As an example, the material safety data sheet introduced, but he must know that the material safety data sheet was used till 2012, and after 2012, the GHS or the Global Harmonized Safety System updated the material safety data sheet to safety data sheet, and the difference was adding 4 sections for the ecology and the environmental hazards introduced by the chemical material. So here, if we talk about, consists of 16 sections giving specific information about hazards. 16 section is for safety data sheet, not material safety data sheet. That was I needed to be updated in the material, but as we see here, the safety data sheet is for the 16 section. In this 16 section, as we see, there are the toxicity information, the permissible exposure limits, and physical data, reactivity, and chemical also data will be provided, and corrosive data, thermal and chemical stability data, and thermodynamic data. You can Google SDS for any hazardous material, and you can see the 16 section. Also, there is a specific what is known as pictograms. It is a type of hello. It is a type of pictograms. It's a type of diagramming that ensuring knowledge about risks. Okay, the process also technology information is the drawing, as we all know, the plug flow diagram or the P&ID. All this drawing act as a technology information. equipment information, the material of construction, and electrical classification and ventilating, as we said. Also, how to the seventh element is the hazard identification, or it's called as a HERA. Quickly, we will talk about the difference between hazard and risk. I think this is a major for you. Hazard is something potential cause for harm. Risk equal hazard plus exposure. So if you don't lose, you don't play. As we said, risk is likelihood in severity, and we talked about the three questions that uh, must be asked to evaluate risk. But here, uh, it is important to know that if the hazard identification or risk assessment is incorrect or done by incompetent person or unrealized for the hazard and risk of the place, the it may cause or raise a major accident by the recommendation or by the controls added. So it must be the one who assesses the risk must well know the place well. Uh, Also, it needs to be independent, but otherwise, it is important to be identified by the need of knowing the place by itself. Okay, we have to go quickly as we need. Okay, this type of risk you can be introduced by itself by yourselves, and any questions can be introduced across the groups. This is also our type of hazard and risk. This is the RAM. Okay, as we have two breaking, this is important. I will talk for this at last. This is an important issue. I want to ensure that you all know it. Risk management is not interchangeable word for risk assessment or risk analysis. Risk management is overall umbrella that must be included underneath risk analysis and risk assessment, and at last it is risk management. If we identify the hazards and evaluate it, this is what is called risk analysis. As we see here, sorry. This phase only is called risk analysis. Here we identify the hazard and judgment by evaluation. If we make it across the RAM or the risk matrix here and considered with the value and compare this value with the allowed, this is the risk assessment. If we conduct the cost benefit analysis study or allowed demonstration from the allowed demonstration, we done the cost benefit analysis and it shows that we have to introduce the control and take a last decision. This is overall what is called risk management. That's how it is important to not to use risk assessment changeable for risk management wording. Here also there are the types of risk analysis. For the shortage of time, I'm sorry, as we have to taking our fasting, so we have to end our session right now. I will leave 3 minutes if anyone has questions or requirement for anything. After that, you have to I am sorry that I can't end the material overall due to the shortage of time. I will leave the material as it is with all its contents. You can read it by yourself. I think you will know what is written and understand it easily. And in any case, any question or any requirement, you can join me on the WhatsApp group, or I think Mr. Ahmed will give you the contact information for my LinkedIn profile. If you need anything, you can communicate with me across the LinkedIn profile or the WhatsApp group for any questions. I'm waiting for if anyone has any question.
Okay, if there is no question, yani we would like to thank you, Mons Islam, for your great and useful session. And thanks for everyone for attending and participating. And inshallah, we'll looking forward to see you in next session, inshallah. Shukran, thank you.
Okay. Okay, thank you all. Goodbye.